Hey guys, we're going to start some Calc 2. We're going to start off with some integrals, but they're a little bit different than the integrals that you know because these integrals have infinities on them. So we actually call them improper integrals. Okay, so improper integrals. Now I've written right here, next to this one it says either one or both of the limits are infinite, so there's infinity sign, or the function has a place of discontinuity that will never work at an asymptote, or like down here, I can never put a 1 right there because that would give me a 0 in the denominator. Okay, that's going to be either at one of the limits or between one of the limits. So now that we've learned improper integrals after today, you can't just start doing an integral that you're used to doing without looking to make sure that it's not improper, which means that there's not a value that I could find near an asymptote or an undefined value. And so I couldn't find an area under the curve as a finite answer. Okay, so on number one of the limits is infinity, so it's an infinite limit, so it's improper. This one, infinite limit. Okay, so those ones are a little bit easier. If I see an infinity sign, I know it's infinite, and I'm going to have to do another method to find the integral. When you get to 3 and 4, now I've got finite numbers that I'm using, my limits of integration, but I need to look and make sure that the graph or that the equation will work at each of these numbers and at every number in between. And it's something you need to stop and do now before you take an integral, now that you know these rules, okay? So if I plug a 1 in here, I get 1 minus 1 is 0. So that is not going to work. It's discontinuous at that limit of 1, okay? Over here, x equals negative 1, it's discontinuous between the limits. So in between negative 2 and 2, I come up with this number negative 1 that is an asymptote. So I can't find the area going up to an asymptote because it goes up forever without breaking it off somehow, okay? So notice that the function doesn't have to be in between, it could also be at the limit. So there's 3 types of things that you're looking for with improper integrals. Okay, so I'm going to do this on a separate paper so that it's not quite as squished and you can see it a little bit better. So on number 1, we're going from 1 to infinity of 1 over x squared dx. So what I want to show you is when I evaluate this integral, I'm starting at 1 and I'm going to infinity. Okay, so I'm trying to find this area under here to see, does this area keep getting bigger and bigger and bigger and bigger that I can't find a number and it diverges? Or is this area under here going to get so tiny that I could cut it off and say it's never going to get big enough to hit more than this one number, and then you can find that area, okay? So I can't ever get to infinity. Infinity is no way to get there. So what do I do when I want to get close to a number, but I can't get to that number? Hopefully you said we want to take a limit, okay? So I'm going to write the limit, and I'm going to call it b. Okay, we're going to say the limit as the value that I plug in approaches infinity. And then instead of infinity, I'm going to write b, from 1 to b, okay? So I'm going to get close to infinity without being infinity. There's no way to be infinity. When you do these problems, they're really tedious. You have to continue your limit all the way down, okay? So your first point is going to have your limit as b approaches infinity and the integral from 1 to b of 1 over x squared dx. My next point is to actually take this integral. So to do this integral, I have to look at this and say, okay, this is x to the negative 2, right? So I'm still going to write my limit. Every single time you are going to be writing the limits, okay? Now, I'm going to take the integral of this. So I add 1 to the power, and I get negative 1. And then I would divide by the negative 1, which is the same on this one as having that negative 1 out there, dx, right? That's your next point, okay? So you get a point for writing the limit, and you get a point for taking the integral, and then you get a point, so we're keeping our limit, sorry about that. I wrote dx instead of my 1 to b. So we need to write that 1 to b here. So now I'm going to plug in my b. So I get negative b to the negative 1 minus negative 1 to the negative 1. This is going to change to plus. And then let's write this one more time. So this part you'd get a point for, okay? This next one, that's up to you if you want to write it or not. I always like to. So this is what I'm going to do. Now that I'm taking infinity and I'm plugging it in for b, okay? So once you plug in the limit, once you evaluate the limit, do not write limit. Okay, so my next step is not going to have a limit in it. My next step is going to be to plug the limit in. So I'm going to write it over here, negative 1 over infinity. Okay, this is negative 1 over a really big number. So negative 1 over 10. Negative 1 over 100, negative 1 over 1,000. As it gets to infinity, it's going towards 0. So this value, negative 1 over b, is just 0. And this value is 1. So 0 plus 1 is 1. That would be your last point. Okay? So lots of points on this assignment for notation. 1, 2, 3, 4. You have to show it one step at a time. Okay, number 2. So now we're doing the integral from 1 to infinity of 1 over x dx. So I want you to look at this graph. And I want you to notice that this one isn't getting as small as fast as this one was. So this part right here, it may just keep growing too much to be able to cut it off and say, I don't need to worry about this part anymore. So we are going to evaluate it and see if we can do that or if it diverges. Okay, so here, first step. B is going to go to infinity, 1 to b. Okay, there's our first step. Now our second step, we're still going to have our limit. But I'm taking the integral of 1 over x, which is the natural log of x, evaluated from 1 to b. Okay? Now I'm going to plug in b, still writing the limit, natural log of b minus the natural log of 1. Okay, and the natural log of 1 goes away, that's 0. And the natural log of infinity is huge, so it diverges. I'm not able to find a value for the natural log of infinity, so I'm going to say that this diverges. I cannot come up with a certain area between 1 and infinity. Okay? Number 3, we're going from 0 to infinity, the cosine of x dx. Again, this has an infinity, so I'm going to go to my limit. Limit as b goes to infinity, 0 to b, cosine of x dx. Okay, so now the integral of cosine is the sine. Remember to write your limit. Sine of x evaluated from 0 to b. See what I mean? How it gets a little tedious. We have to keep writing this every single time. Okay, so the sine of 0 is just 0. And the sine of infinity, think about a sine graph. It goes up to 1 and down to -1 and up to 1 and down to -1. So depending on where you are as you go to infinity, you have to say that that will not work. Okay, so this is also going to diverge. I'm not able to come up with an exact number for the sign from 0 to infinity because it oscillates. All right, example 4. So there's 2 left. We've got example 4 and example 5. Okay, so we've got -1 to infinity of x e to the negative x. Now I notice there's an infinity here, so I'm going to write my limit. 1 to b. Okay. Next step is to take this integral, right? And we know that we can do this using tabular or we can do integration by parts. I'm going to show you both ways so that you can see the notation for both, okay? So if I do tabular, I'm going to have an x, and the derivative of x is 1, and the derivative of 1 is 0, and then my sign starts at a positive, goes to a negative, and a positive, okay? And then e to the negative x, the integral of e to the negative x is negative e to the negative x. The integral of negative e to the negative x is again negative, but it's already negative, so this one's going to be positive e to the negative x. So I'm going to write my limit as b approaches infinity. And this time I've already taken the integral, so I'm just going to write the negative x e to the negative x minus e to the negative x. And that whole thing is evaluated from 1 to b. Okay? So this is the first point, to have the limit. And then this would be the next point, to show the integral. Now, the other way I could do this integral is I could do integration by parts. And I could say u is x. The derivative of x is dx. The other part is e to the negative x dx. And the integral of that is negative e to the negative x. Okay? Integration by parts, I do VU and then voodoo, right? Or ultraviolet voodoo. So I'm going to say the limit as b approaches infinity. And we're going to set that u times v, so negative x, e to the negative x. And that's evaluated from 1 to b. Okay? And then it's minus the integral of negative e to the negative x dx. And this is going to cancel out and give us a positive from 1 to b. So this would be the second step when you do integration by parts. So I'm still going to write the negative x e to the negative x. And then I'm going to take this integral. So the integral of e to the negative x is negative e to the negative x. And both terms are evaluated from 1 to b. So see how I got the same thing? Always good to do the same thing and make sure you get your signs the same. Okay? So now from here, I'm doing the same thing. So now I'm going to plug b in. So I get the limit as b approaches infinity of negative b. And then if I plug a b in here, negative b is going to be 1 over e to the b. So I'm just going to put e to the b right here. Minus another 1 over e to the b. This one had an x in front, so that's why there's a b here. And this one had a 1 in front, so that's why it's a 1. Okay? So I've plugged in the b. Now I'm plugging in the 1. So negative e to the negative x minus e to the negative x. So I have 2 of these, and x is actually 1, right? So that's just going to be negative 1 over e minus another negative 1 over e is going to be negative 2 over e. Then the negative is going to cancel out. So let's write that. Over e. Okay. All right, now we plug our infinity in. So if I have negative b, I have an infinity. Let's do it this way. I'm going to infinity. So this is going to be slow, and this is going to be fast, right? Same with this, slow and fast. So this is 0, 0, and then 2 over e. So our answer is just 2 over e, because this part of it is just 0. Okay? All right, our last example, number 5. Negative 1 to 2, 1 over x cubed dx. That's pretty tempting to just start taking this integral, right? But I need to notice that at 0, this is undefined. There's a vertical asymptote at x equals 0, and that is in between my negative 1 and 2. So what I have to do here is actually write two separate integrals. I have to do the integral, I'm not drawing the graph exactly, but on the way, so this integral, and then on the way back, this integral. And I have to separate it and do this integral plus this integral, okay? So we're going to do this one as b, and we'll call this one as a. This one is approaching 0 from the left side. This one is approaching 0 from the right side. Okay, so we're going to write two separate integrals. First of all, it goes from negative 1, and then it's going to stop at 0. So I'm going to have the limit as b approaches 0 is where I'm stopping, but I'm on the left side of 0, so I'm going to put a minus sign here. Okay, so we're going from the left side of the integral from negative 1 to b, 1 over x cubed dx, and I'm going to add, so this integral is going to be added to the other integral, and remember we called that a, so let's say a approaches 0, and this time it's approaching 0 from the right, 1 over x cubed dx. Okay, so there's my first point for setting up the limits. Maybe we'd get 2, 1 for this one and 1 for that one. And now I'm going to take the integral, so I'm still writing my limit. The integral of x to the negative 3 is going to be, I'm going to add 1, I get a negative 2 power, and then I divide by a negative 2. So it's actually going to be negative 1/2 x squared. And that's evaluated from negative 1 to b. Okay. And then we've got our, and actually I don't want the x squared up top because this x squared was in the bottom. Okay, and then here I'm going to have plus, now I already know what this integral is, right? So I'm still going to write the limit, a approaches 0 from the right, negative 1 over 2x squared, evaluated from, now this one I'm going negative 1 to b, on this one we're going a to 2, right? And it really doesn't matter if you call this b, okay? It's just a placement for that 0 that I can't put in. So now I'm going to evaluate these at each of their values. So b is approaching 0 on the left is negative 1/2 b squared minus 1/2 times negative 1 squared plus the limit as a approaches 0 on the right, plugging a 2 in this time. So negative 1 over 2 times 2 squared, so 1/8 minus negative 1 over 2a squared. So this is going to change to plus. This one is not going to change to plus. Okay. So when we evaluate this, we're going to have, this actually is going to change to plus because this is negative and we're subtracting. So that's going to be plus. Okay. Just make sure I've got the signs right. Okay, good. So now I'm going to plug in 0 down here. So 0 from the left is getting closer and closer and closer to 0. So I'm looking at a fraction, okay? As I get closer to 0, I'm looking at 1/10, 1/1000, 1/1,000,000, okay? So I'm looking at -1 over 2 over infinity, okay? So if I look at this, 2 over infinity is just infinity. And this whole thing diverges. So I can't have one of these diverge and one of these not diverge and then come up with a number and say, well, I can add these parts. You have to be able to find a number for this and a number for this. If you can't, then it's going to diverge, and there's no way to find that area. Okay. All right, so work on those review problems. Let me know if you have any questions, and we will talk about this tomorrow. Have a great night.